Floor grounding receptacles can indeed be used in a Class 1, Division 2 classified space. However, there's a crucial stipulation: any electrical equipment, including these receptacles, that is installed within a Class 1, Division 2 classified space must be specifically identified and approved for that particular use. This identification ensures that the equipment is designed and constructed to prevent ignition of flammable vapors or gases that might be present in such environments. Now, regarding the bonding cable that connects these receptacles, the classification doesn't automatically default to Class 1, Division 1 simply because it's located below the slab. The key factor is the classification of the space where the cable is situated. If the bonding cable is also located within a Class 1, Division 2 classified space, it's generally considered Class 1, Division 2 as well, regardless of its physical location in relation to the floor or slab. Let's delve a little deeper into these concepts. A Class 1 location, as defined by the National Electrical Code, is a location where flammable gases or vapors are or may be present in the area in quantity sufficient to produce explosive or ignitable mixtures. These locations are further subdivided into divisions based on the likelihood of the presence of such flammable materials. Division 1 signifies a location where ignitable concentrations of flammable gases or vapors exist under normal operating conditions, or where such concentrations may exist frequently because of repair or maintenance operations or because of leakage, or where breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases or vapors and might also cause simultaneous failure of electrical equipment. Division 2, on the other hand, signifies a location where ignitable concentrations of flammable gases or vapors are not normally present in the air, or where ignitable concentrations are normally prevented by positive mechanical ventilation, and which might become hazardous only through failure or abnormal operation of the ventilating equipment, or where it is adjacent to a Class 1, Division 1 location, and occasionally ignitable concentrations of flammable gases or vapors might be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. In a specific context of aircraft hangars, Article 513 of the National Electrical Code provides detailed requirements for electrical wiring and equipment. It often designates the entire floor area of a hangar as a Class 1, Division 2 classified location up to a certain height above the floor, typically 18 inches, as mentioned in the question. This classification recognizes the potential for flammable aviation fuels and vapors to accumulate near the floor. Therefore, any electrical equipment installed within the zone must be suitable for use in a Class 1, Division 2 environment. Grounding is another critical aspect of electrical safety in aircraft hangars. NFPA 70, the National Electrical Code, emphasizes the importance of grounding to remove and control static electrical accumulations. Static electricity can pose a significant ignition hazard in areas where flammable liquids or vapors are present. Grounding systems provide a path for static charges to dissipate safely to ground, minimizing the risk of sparks and potential explosions. Floor grounding receptacles are commonly used in hangars to facilitate the grounding of aircraft and other equipment. These receptacles are connected to a grounding system that ensures a low-resistance path to Earth. The grounding system typically consists of a network of conductors and grounding electrodes that are installed in accordance with the requirements of the National Electrical Code. When selecting floor grounding receptacles for use in a Class 1, Division 2 location, it's essential to choose receptacles that are specifically listed or labeled for that purpose. These receptacles are designed to prevent the ignition of flammable vapors or gases. They typically have features such as explosion-proof enclosures, sealed contacts, and other safeguards. The listing or labeling of the receptacle indicates that it has been tested and certified by a recognized testing laboratory to meet the applicable safety standards for Class 1, Division 2 locations. The bonding cable that connects the floor grounding receptacles is an integral part of the grounding system. This cable provides a low-impedance path for fault currents to flow back to the source, which helps to ensure that overcurrent protective devices, such as circuit breakers or fuses, will operate quickly to clear faults. The size and type of bonding cable must be selected in accordance with the requirements of the National Electrical Code. The code specifies minimum conductor sizes for grounding and bonding conductors, based on the size of the overcurrent protective device protecting the circuit. The bonding cable must also be suitable for the environmental conditions in which it is installed. If the cable is exposed to corrosive substances or moisture, it must be made of a corrosion-resistant material or be protected by a suitable coating. While the location of the bonding cable below the slab might raise concerns about its classification, it's important to consider the overall classification of the area where the cable is located. If the space below the slab is also considered Class 1, Division 2, then the bonding cable would typically be classified as Class 1, Division 2 as well. However, if the space below the slab is not classified, then the bonding cable would not need to be classified. In some cases, it might be possible to use a non-classified cable, provided that it is installed in a suitable conduit or raceway system that provides adequate protection against physical damage and environmental factors. It's always recommended to consult with a qualified electrical engineer or inspector to determine the appropriate classification and installation requirements for the bonding cable. In summary, the use of floor grounding receptacles in Class 1, Division 2 locations is permissible, provided that the receptacles are specifically identified for such use. The bonding cable between the receptacles is typically classified according to the classification of the space where it is located. Grounding and bonding are essential safety measures in aircraft hangars and other hazardous locations, and it's crucial to follow the requirements of the National Electrical Code to ensure a safe and reliable electrical system. Let's expand further on the practical considerations and code requirements related to grounding and bonding in Class 1, Division 2 locations, particularly within aircraft hangars. Firstly, it's crucial to understand that the National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated regularly to reflect the latest advancements in technology and safety practices. Article 513 of the NEC specifically addresses aircraft hangars and provides detailed requirements for electrical installations in these locations. The NEC emphasizes the importance of minimizing the risk of fire and explosion in areas where flammable liquids or vapors are present. To achieve this, it mandates the use of explosion-proof or intrinsically safe equipment in Class 1, Division 1 locations, and it allows the use of equipment suitable for Class 1, Division 2 locations in areas where flammable materials are less likely to be present under normal operating conditions. When selecting electrical equipment for use in a Class 1, Division 2 location, it's essential to look for equipment that is specifically listed or labeled for that purpose. This listing or labeling indicates that the equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, or Intertek, to meet the applicable safety standards. The equipment should be marked with the class and division for which it is approved, as well as any other relevant information, such as the temperature code. The temperature code indicates the maximum surface temperature that the equipment will reach under normal operating conditions. This is important because flammable materials have different ignition temperatures, and it's crucial to ensure that the surface temperature of the equipment does not exceed the ignition temperature of any flammable materials that might be present in the area. In addition to selecting appropriate equipment, it's also important to follow the NEC requirements for wiring methods in Class 1, Division 2 locations. The NEC specifies that wiring in these locations must be installed in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. The raceways must be sealed to prevent the entry of flammable vapors or gases. The NEC also requires the use of explosion-proof fittings and boxes in Class 1, Division 2 locations. These fittings and boxes are designed to contain any explosion that might occur within them, preventing the ignition of flammable materials outside the enclosure. Grounding and bonding are critical aspects of electrical safety in all locations, but they are particularly important in Class 1, Division 2 locations. The NEC requires that all metal enclosures and equipment be properly grounded to provide a low impedance path for fault current to flow back to the source. This helps to ensure that overcurrent protective devices will operate quickly to clear a fault, minimizing the risk of electric shock and fire. Bonding is the process of connecting together all metal parts that are not intended to carry current. This includes metal conduits, metal enclosures, metal equipment frames, and metal piping systems. Bonding helps to equalize the voltage potential between these metal parts, reducing the risk of electric shock. The NEC specifies minimum conductor sizes for grounding and bonding conductors. The size of the grounding conductor is based on the size of the overcurrent protective device protecting the circuit. The size of the bonding conductor is based on the size of the largest ungrounded conductor in the circuit. The NEC also requires that grounding and bonding conductors be installed in a continuous, unbroken path. This means that the conductors must not be spliced or interrupted in any way. Splices and terminations must be made using approved connectors and fittings. In aircraft hangars, it's particularly important to ground the aircraft itself. This is typically done using a grounding cable that is connected to a grounding receptacle in the floor. The grounding cable should be of sufficient size to carry the expected fault current, and it should be connected to a grounding electrode system that is properly installed in accordance with the NEC. The grounding electrode system typically consists of one or more ground rods, ground plates, or underground metallic water pipes that are connected together to form a low resistance path to earth. The resistance of the grounding electrode system should be measured periodically to ensure that it is within acceptable limits. If the resistance is too high, the grounding electrode system may need to be improved by adding additional ground rods or plates. In addition to grounding the aircraft, it's also important to ground any other equipment that might be used in the hangar, such as fuel trucks, maintenance equipment, and portable lighting. This equipment should be grounded using grounding cables that are connected to grounding receptacles in the floor or to a common grounding busbar. The grounding cables should be of sufficient size to carry the expected fault current, and they should be inspected regularly to ensure that they are in good condition. In summary, electrical safety in Class 1, Division 2 locations requires careful attention to detail. It's essential to select equipment that is specifically listed or labeled for use in these locations, to follow the NEC requirements for wiring methods, and to ensure that all metal enclosures and equipment are properly grounded and bonded. In aircraft hangars, it's particularly important to ground the aircraft itself and any other equipment that might be used in the hangar. By following these safety precautions, you can minimize the risk of fire, explosion, and electric shock in Class 1, Division 2 locations. Now, let's delve deeper into specific scenarios and considerations within aircraft hangars, focusing on grounding practices and potential challenges. Firstly, consider the situation where an aircraft hangar is undergoing renovations or modifications. During such projects, it's crucial to ensure that any temporary electrical installations are also compliant with the NEC requirements for Class 1, Division 2 locations. This includes temporary lighting, power distribution units, and extension cords. All temporary equipment should be listed or labeled for use in Class 1, Division 2 locations, and it should be properly grounded and bonded. Furthermore, any temporary wiring should be installed in accordance with the NEC requirements for wiring methods in Class 1, Division 2 locations. This might involve the use of rigid metal conduit, intermediate metal conduit, or other approved raceways. The raceways should be sealed to prevent the entry of flammable vapors or gases. Another important consideration is the maintenance of electrical equipment in aircraft hangars. Regular inspections should be conducted to ensure that all equipment is in good working order and that there are no signs of damage or deterioration. Any damaged or defective equipment should be repaired or replaced immediately. The grounding and bonding system should also be inspected regularly to ensure that it is intact and that the resistance of the grounding electrode system is within acceptable limits. In addition to regular inspections, it's also important to perform periodic testing of electrical equipment in aircraft hangars. This might include testing of ground fault circuit interrupters, or GFCIs, insulation resistance testing, and continuity testing. These tests can help to identify potential problems before they become serious hazards. When working on electrical equipment in aircraft hangars, it's essential to follow safe work practices. This includes de-energizing the equipment before working on it, using appropriate personal protective equipment, or PPE, and following lockout/tagout procedures to prevent accidental energization. Only qualified personnel should be allowed to work on electrical equipment in aircraft hangars. Qualified personnel are those who have received the necessary training and experience to safely perform electrical work in hazardous locations. They should be familiar with the NEC requirements for Class 1, Division 2 locations, and they should be able to identify potential hazards and take appropriate precautions. Furthermore, it's crucial to have a comprehensive emergency plan in place for aircraft hangars. This plan should include procedures for responding to fires, explosions, and other emergencies. The plan should also identify the location of emergency equipment, such as fire extinguishers, emergency shut-off switches, and first aid kits. All personnel working in aircraft hangars should be familiar with the emergency plan, and they should be trained on how to respond to emergencies. Now, let's consider the specific case of aircraft hangars that are used for painting or refinishing aircraft. These hangars present additional hazards due to the presence of flammable paints and solvents. The NEC requires that these hangars be classified as Class 1, Division 1 locations throughout the entire area where painting or refinishing is performed. This means that all electrical equipment in these areas must be explosion-proof or intrinsically safe. In addition to the NEC requirements, there are also other regulations and standards that apply to aircraft painting and refinishing operations. These regulations and standards are typically issued by federal, state, and local agencies. They address issues such as ventilation, fire protection, and waste disposal. It's important to be familiar with all applicable regulations and standards before performing aircraft painting or refinishing operations. In summary, electrical safety in aircraft hangars requires a comprehensive approach that includes proper equipment selection, installation, maintenance, and safe work practices. It's essential to follow the NEC requirements for Class 1, Division 2 locations, and to be aware of any other applicable regulations and standards. By taking these precautions, you can minimize the risk of fire, explosion, and electric shock in aircraft hangars. Finally, let's discuss the evolving landscape of electrical safety and technology in aircraft hangars. As technology advances, new types of electrical equipment and systems are being introduced into aircraft hangars. These new technologies offer potential benefits in terms of efficiency, productivity, and safety. However, they also present new challenges in terms of electrical safety. For example, the increasing use of electronic devices in aircraft hangars requires careful consideration of electromagnetic compatibility, or EMC. EMC is the ability of electronic devices to operate without interfering with each other. If electronic devices are not properly designed and installed, they can generate electromagnetic interference that can disrupt the operation of other devices or even create safety hazards. Another emerging technology in aircraft hangars is the use of renewable energy sources such as solar panels and wind turbines. These renewable energy sources can help to reduce the hangar's reliance on fossil fuels and lower its energy costs. However, they also require careful consideration of electrical safety. Solar panels and wind turbines generate direct current, or DC, electricity, which can be more hazardous than alternating current, or AC, electricity. Special precautions must be taken when working with DC electricity to prevent electric shock. In addition to new technologies, there are also ongoing efforts to improve existing electrical safety standards and practices. The NEC is constantly being updated to reflect the latest advancements in technology and safety knowledge. There are also numerous industry organizations and research institutions that are working to develop new and improved electrical safety standards and practices. As the electrical safety landscape continues to evolve, it's important to stay informed about the latest developments. This can be done by attending industry conferences, reading trade publications, and participating in online forums and discussions. By staying informed, you can ensure that you are using the best available technologies and practices to protect yourself and others from electrical hazards in aircraft hangars. In conclusion, electrical safety in aircraft hangars is a complex and multifaceted issue that requires a comprehensive and ongoing effort. By understanding the NEC requirements for Class 1 Division 2 locations, following safe work practices, and staying informed about the latest developments in electrical safety and technology, you can help to minimize the risk of fire, explosion, and electric shock in aircraft hangars.